Today we are going to discuss a case study on a failure of a vehicle gear. Okay, so as we see, sometimes gear may fail. Okay, in spite of any design or any type of process undergoing, it may fail. Okay, so you can see most probably the gears are employed in the gearboxes. Okay, the gears are mainly employed in the gearboxes. Where these gearboxes are employed is in turn used as an application of bus. Okay, the gearbox are used in starting from a small vehicle to big vehicles. Okay, it is used as a transmission gearboxes. These vehicle gears are used. Okay, next. So here you can see again the vehicle gears are getting failed in a bus gearbox. Okay, so this is the introduction about it. It is the vehicle gear is AISI 86203. So it has been used for 3 years. So the service time is 3 years. It is mainly used in the gearboxes where for this type of case study we are using these evaluation methods to find exactly what is the root cause for this failure. Okay, next. So when we spoke about gear failure, we can say a particular gear may get failure due to fatigue. Sometimes to fatigue, it's because it is used in high speed machines. It can be failure due to impact, it can be failure due to fracture, it can be failure due to wear, that is same one. Okay, sometimes due to stressing. Okay, next. So, what are the causes for failure apart from this? Okay. Okay. Overload, right? Okay, right. The uses of incline okay, so in by lining it up, we can say it is due to improper design, improper process, overloading, misalignment, right? Okay, next. Okay, this is the case study what we are going to discuss it now. Next. So this is the gear which is got failure. You can see this is the pick where the gear got failure. Okay, next. So this is the value. Okay, move on.
So the analysis of the micro harness, we have core harness of 439 Vickers harness and surface harness of 550 Vickers harness. And the case depth is 0.63 mm, and it is the more micro harness consists of major martin say and the retained oscillators.
So this is a gear where, as our friend said, see, for a gear only the outer surface is going to have a high impact or high machine part. So at that time this should be hard and high, means that it should have high hardness, it should have less hardness. Okay, so nowadays we are using surface hardness methods to harden the gears. It's because only the surface is going to get impact or going to machine or going to go somewhere. So only it has written as core hardness means this is the inner core, it is 439 and outer core is 550. Okay, so apart from this, from the microstructure analysis, it is said that as our friend said, it is the mortar side and the retained side. Next. So this is the one. Here, this white color is retained side and this black color are the okay, sorry, mortar side. Next.
So visual inspection, but we can see the number of teeth which are mentioned, number of teeth failed due to cutting. Here we can see before the slide we have seen the microstructure where the fatigue have been failed in the number of teeth. Then the triangular piece of teeth have broken off. Here you can see the triangular teeth of gear which have been broken off. Then the crack initiation and benchmarks can be seen by the naked eyes. As without microscope in a naked eyes itself, we can visually interpret that some of the crack initiation, the beginning of the crack can be seen throughout naked eyes itself. So it can be done through visual inspection. Then as I said, the hardness and the mostly mechanism based on the outer surface. So the crack initiation mostly starts at the outer surface of
Means where the machine is going to happen, where the crack will go.
So coming to the fitting, if the load is over, it starts to fitting. The fitting is nothing but the machine of two layers is known as the fitting. As you can see, this area got fitted due to overload. So it is fitting. So coming back to the image, you can see. So you can see that at distance in pitting, respective pitting. So near to that, you can see the sapling no. Spalling. So the distributive pitting is the after stage of cracking.
So someone some examination, even like pattern we see in proper zone.
Next. See, this is the same image where it's taken standing at the microscope, where you can see this is the river-like mass. So if the crack started here, the crack wants to move up to from this area. So this is the crack located here. Means, this looks like a river map. See, if you go and stand on the banks of the river or bank of say on the seashore, if the water comes and